Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is surface chemistry. So first of all, what is adsorption? The phenomena of accumulation of molecules at the surface of a solid which results in higher concentration on the surface than in the bulk. Then adsorbate is the substance which gets adsorbed, and adsorbent is the substance on which adsorption takes place. Desorption, the phenomena of removing an adsorbate from an adsorbent. There are two types of adsorption, physical and chemical. Physical is called as physiosorption and chemical adsorption is called as chemisorption. Gases adsorb in almost all solids, and factors on which the extent of adsorption of a gas on a solid depends upon nature of the gas, nature of the solid, surface area, pressure, and the temperature. Adsorption isotherm, the relation between the extent of adsorption and the pressure of a gas at the constant temperature. Application of adsorption. Production of high vacuum, gas mask, silica and aluminium gels are used as adsorbents for controlling humidity. A number of drugs are used for killing germs. The drug gets adsorbed on the germs used in heterogeneous catalysis, used in chromatographic analysis. The substance which alters the rate of reaction but itself remains chemically and quantitatively unaltered after the reaction is called as catalyst. Phenomena of fusing of catalyst is called as catalysis, and the substance which enhances the activity of a catalyst are called promoters. The substance which decrease the activity of a catalyst are called poisons, and broadly divided into two groups: homogeneous catalysis and heterogeneous catalysis. In homogeneous catalysis, the reactants and the catalyst are in same phase, and the heterogeneous catalysis, the reactants and the catalyst are in the different phase. Then shape selective catalysis that depends upon the pore structure of the catalyst and the size of the reactant and the product. Then enzyme catalysis or biochemical catalysis. An enzyme acts as the catalyst, highly specific in nature, highly active under optimum temperature and pH, and influenced by inhibitors and poisons. Industrial catalytic process, Haber's process, Ostwald process, and contact process. Then colloids. Heterogeneous system, intermediate between true solutions and suspensions, then consists of two phases, dispersal phase and dispersion medium. Classification of colloids are classified depending upon the following three criteria: dispersed phase, dispersion medium, and types of colloid. If both are solid, then the type of colloid is solid solution, and one is solid and another is liquid, then solid, like this. The nature of the interaction between the dispersed phase and dispersion medium: lipophilic colloids, yani solvent attracting, also called reversible salt solutions, quite stable and cannot be easily coagulated. Then lyophobic colloids, solvent repelling, also called irreversible solutions and can be easily coagulated. Type of particles in the dispersed phase: multimolecular colloids, macromolecular colloids, and associated colloids. The temperature above which the formation of micelles takes place is called as Kraft temperature, TK, and the concentration above which the formation of micelles takes place is called as critical micelle concentration. Then preparation of colloids, chemical method, electrical disintegration of Bredig arcs method, then baptization, process of converting a precipitate into colloidal solution by shaking it with the dispersion medium in the presence of small amount of electrolyte. Then purification of colloidal solution, reduction of the amount of impurities to a requisite minimum. Dialysis is the process of removing a dissolved substance by diffusion through a suitable membrane. Electrodialysis and ultrafiltration. Properties of colloidal solution: colligative properties, Tyndall effect, color, Brownian movement, and charge on colloidal particles. Electrophoresis: movement of colloidal particles under applied electric potential. Electroosmosis: movement of dispersion medium through membrane in an applied electric field. Then coagulation or precipitation: process of settling of colloidal particles. Ways to carry out coagulation of solutions are by electrophoresis, by mixing two opposite charged solutions, by boiling, by persistent dialysis, by adding of electrolytes, and by Hardy-Schlegel rule. The greater the valence of the flocculating ion added, the greater is its power to cause precipitation. Then emulsion, a colloidal system. Both the dispersed phase and the dispersion mediums are liquid. There are two types: oil dispersed in water and water dispersed in oil. Emulsifying agent. The third compound used for stabilizing an emulsion. Emulsification is the process of making an emulsion. Application of colloids: purification of drinking water, colloidal medicines. Example: milk of magnesia and emulsion. Cleansing action of soaps and detergents, photographic plates of films, rubber industries, and many more. And this is the electrical precipitation of the smoke. So this much for today's video. Hope you liked it and understood it. Thank you for watching my video. Till then, bye bye. Thank you.